Mars, the red planet. For centuries, this mysterious world has captivated our imaginations. But what would it really be like for humans to live there? NASA is on a journey to send astronauts to Mars as early as the 2030s. Living on Mars would be the adventure of a lifetime, but it would also be incredibly challenging. Let's explore the realities of life on the red planet. Mars is a harsh and unforgiving environment. Astronauts would face 5 main hazards. Number 1. Radiation exposure from cosmic rays and solar particle events, with no protective magnetic field or dense atmosphere. Over a 2 to 3 year mission, radiation levels could approach NASA's career limit for astronauts. Number 2. Isolation and confinement. A round-trip mission would take about 500 days in transit, plus time on the surface, with communication delays up to 24 minutes each way. Astronauts would have to cope with extreme isolation. Number 3. Distance from Earth. Resupply missions would be limited. Astronauts would need to be largely self-sufficient and deal with emergencies on their own. Number 4. Reduced gravity. Mars has about 1 to 3 of Earth's gravity. Long-term health effects are still unknown, but could include bone and muscle loss and vision problems. Number 5. Extreme environment. Temperatures range from -284 Fahrenheit to -86 Fahrenheit. The thin CO2 atmosphere provides no breathable oxygen. Dust storms can cover the whole planet for months. So how can humans possibly live in such an extreme place? Through the power of innovation and technology, NASA is developing an array of cutting-edge technologies to meet the challenges of Mars, like the spacesuits astronauts will wear. Essentially, a custom mini spacecraft. The suits will provide oxygen, remove CO2, regulate temperature and pressure, and shield from radiation, all while still allowing flexibility to explore. Astronauts will traverse the Martian surface in pressurized rovers, like an RV on wheels. The rover serves as both habitat and mobile lab, with onboard life support, radiation shielding, and everything needed to live and work for weeks at a time. Power will likely come from a nuclear fission system, providing reliable energy day and night, and during global dust storms when solar power is diminished. Water and oxygen won't need to be carried from Earth. They can be extracted from subsurface ice deposits and the CO2-rich atmosphere using specialized processing systems. 3D printers could even use Martian regolith to construct landing pads, roads, and habitats. Many of these technologies will be demonstrated first on the Moon, through NASA's Artemis program, before being deployed on Mars. So what might a mission to Mars look like? First, precursor missions in the 2020s will validate transportation and habitation capabilities. In the early 2030s, cargo missions will pre-position supplies and equipment on the Martian surface. The crew will then launch in a Mars transit vehicle for the 6 to 9 month journey. Once in Mars orbit, the crew will rendezvous with a pre-landed habitat and use a lander to descend to the surface. They'll spend up to 500 days living and working on Mars, conducting scientific research and exploration. For the return trip, the crew will use a Mars ascent vehicle to launch from the surface and rendezvous with their transit vehicle in Mars orbit for the journey home to Earth. The total mission duration could be 2 to 3 years. The first humans to set foot on Mars will be true pioneers, ushering in a new era of exploration. Through dedication, ingenuity, and technological innovation, the dream of living on Mars is on the verge of becoming reality. One day, the first human footprints will join the rover tracks in the red Martian regolith. We'll become a 2-planet species as humans begin to build a permanent presence beyond Earth.